This is an extended lesson on energy diagrams. So let's start from the very beginning and think about our machine. Now we're just going to focus on the very end part of our machine so we can really show that we are thinking about how to analyze not just the changes that we've made, but for the higher level marks, how that's affected the energy of the marble as it moves through the machine. Because you had a choice of different things you could change, and the idea was that if you changed one of those variables, that it would improve the amount of energy that the marble had as it flowed through the machine. And as you know, the more energy you have, the faster you can move. So the whole aim of the game was to try and get that marble to exit as fast as possible. So let's have a little look at the energy and how we actually can analyze this. First of all, you have to break it down and think, where did I start, where did I go to, and what type of energy was there when I was in those places. So when we think about our start, at the start it always has some sort of stored energy, something that to start you off with. Now in this case the energy, as we all know, is some sort of, if it's stored, potential energy. I'm not going to tell you what type, but you think about it, what type of potential energy it must have there. Then as it's traveling down our ramp down here, it's going to have some type of active energy, and in this case, of course, any type of active energy is going to be some sort of kinetic energy, and you have to actually talk about that. As it's going down the ramp, it's going to have some sort of kinetic energy here. When it gets to the bottom of the ramp, it's falling, and then it goes down the next one here, which is a tube, and as it moves down that tube again, it's moving, so it's going to have some sort of kinetic energy. So we've got potential energy and kinetic energy, but we have to have a little bit more of a look and see what's happening to those energies at each point there. But this little outline that I've given you here is actually really good for starting up or scaffolding your energy chain. So let's have a look at it a little bit further. When we write up our energy chain, we're going to talk about the stored energy, the energy it has when it's moving in the ramp and the tube first. So first of all here we've got our stored energy. It's going to be some sort of potential energy. You have to talk to me about the kinetic energy it has when it's moving down the ramp and the kinetic energy that it has when it's moving down the tube. Now we have to take into account the energy that it's losing as it moves, because you do actually hear sound, there is some friction there. There's always friction when something is touching something else, so you have to take that into account. So as it's going down this ramp, it is speeding up and getting faster as the potential energy turns into kinetic energy, but it's also losing some energy. Not all of it makes it to the end of the ramp, and so it's going to be losing some energy as it goes down, and you have to tell me what type of energy it's losing as it goes down. And it's always going to be losing energy as it's moving along any sort of object. If there's any touching or friction of any kind, it's going to be losing energy, and you have to tell me what it is actually losing. Now the other thing we have to think about is the fact that we have an area there where we actually fall from the ramp to the tube. Believe it or not, if you actually look here, you've actually got a drop down the ramp from top to bottom. Finish that, but then it drops again, and that little drop there has a whole heap of extra energy added. Now what type of energy you're going to have to think about, but we've definitely got some energy added in as it falls from the ramp to the tube. Think about it. If you're running along to take a flying leap off a small safe cliff and then going to drop into the water to create a big splash, you think about it. If the person is just standing there and steps off, they might step off, but they're not going to hit the water with as big a splash as someone who's running along and jumps off. They're going to hit the water with a bigger splash. Why? Because they have more energy. Okay? That's because if you're already running along and then you fall, you're adding in some extra potential energy as you go from horizontal to the vertical drop. You need to try and talk to me about what type of energy is added in. Now, where I'm putting these arrows here is not entirely correct. That's deliberate. I just want to give you a scaffold for your energy diagrams. I don't want to give you the exact perfect one. We're definitely going to have some energy coming into this energy diagram here because of the fall, and we're also going to have, of course, as we just said, some energy leaving because as it's moving along the ramp and moving into the tube, it's actually got a whole heap of friction happening there, so some types of energy are going to be leaving as well. So energy diagrams analyze the basic energy that you have at every stage, and then they talk about what energy you lose along the way and if you gain any energy along the way. And then they identify exactly what type of energy that is. You're going to have to do that. That's part of your job here. Now let's go on to a much higher level, just for those of you who like detail. Rather than just talk about the fact of whether or not some energy is lost or energy gained, most scientists, when they get up into the higher levels, really like to measure how much is gained and how much is lost. Why would we want to know how much is gained or lost? Well, when you think about it, energy efficiency is one of the biggest things that we need to look at in today's world, because if things are not energy efficient, if they're constantly losing energy and not really putting that energy into the task at hand, which in this case is to get the ball to the bottom of the ramp, if they're losing a lot of that energy before it gets to the end, then it's not a very efficient machine. And we actually do energy efficiency tests on every single machine around. So Sankey diagrams helped us to picture that energy loss or energy gain. Now, you don't have to put numbers in, although normally scientists do put numbers in, but in a Sankey diagram it looks like this. But the Sankey diagram just helps us to figure out or try and show roughly how much energy we think it is losing or gaining. If you're a scientist, we actually measure this very accurately, and each one of these arrows is proportional to the amount of energy lost or gained. But in this case, we're just going to do it in quite roughly. So first of all, we've got our potential energy, and it's a certain amount here. This distance here reflects how much energy we start off with. Notice that as you get to the bottom of the ramp here, it's lost some energy. Why? Because some of that energy there has disappeared off as some type of wasted energy. And again, you have to tell me what type it is. Then it gets to the ramp, and as it's going down the ramp, it's got kinetic energy. The potential energy turns into kinetic energy or transforms. And again, it is losing energy as it's going down that ramp. So as you can see, the arrow is getting smaller and smaller. However, I've tried to stick a little extra bit in here just to draw the fact that some energy is also going in here because of the fall. Okay, so at the same time as it's losing energy, it's gaining energy at some point as well. And the size of your arrow should reflect the size of the energy that's increased. Okay, so Sankey diagrams try and reflect how much energy we think is going in, how much energy we think is going out, and it just tells the story in a lot more detail when you're trying to analyze the energy efficiency of a particular machine. So these are actually quite common diagrams that you can search up. Every machine has this sort of analysis done when they're trying to look at its energy efficiency. So you can actually Google these and see what people have come up with from their tests. And the Sankey diagram tells us where the machine is losing energy, how much energy it's losing, how much energy actually makes it to the end, which allows our marble to exit the tube with as much speed as possible. That's the Sankey diagram. So you can actually try and draw up one of these as best you can. You're going to be getting assessed on the detail that you put in here with regards to the types of energy and what stage they're at, the types of energy that are being wasted, the type of energy that's entering due to the fall, and basically the overall Also the neatness of the diagram, because yes, you need to actually be able to communicate with diagrams neatly, and if you can't, then that actually does take away from your marks. So definitely try and draw it up as best you can. So that is how to draw a detailed energy diagram. So now, whether it's Sankey diagram or the basic one here, where you're actually talking to me about the wasted energy and the energy that's moving through your machine, that energy diagram that you first draw is your version 1. Okay, so your original machine. What was its energy diagram looking like? The next thing you have to tell me is, how did your change affect the energy as it went in and through version 2? So your version 2 machine is going to look slightly different to this. And you can actually just take the same diagram and make changes on it. That's fine. But you need to show me how version 2 is different. So whether you changed the mass or the angle of your ramps or took out some friction mats, how did that then change this energy diagram here? How did it change it? Now you need to show me how it changed it. So think of a few things. When it comes to mass, the bigger they are, the harder they fall. That is very true. In other words, the bigger you are, the more potential energy you have, and so you're going to hit the ground harder. So your mass is going to affect the energy that you start with. Okay? The bigger they are, the harder they fall. Now think about angle. When it comes to angles, it's a little bit different, because some of you opted to make the angles a lot steeper so that you would hopefully get the marble going a lot faster by the time it got to the end of the ramp. So think of it. If you have a ramp that's just going down on a very basic angle like this, and it's not too steep, it's going to travel a certain horizontal distance, and at the same time it's going to drop this vertical distance. Now it's that dropping there that allows it to accelerate, and as it accelerates, it's going to get faster and faster and faster, because that distance drop there is what affects its gravitational potential energy at the top of the ramp. If you have a ramp that looks like this instead, and I've seen some people do this, you think about it, what's changed? You have changed the height. And because of that, it's going to drop further, okay? And the further you drop, as you know, gravitational potential energy, it's affected by a few things. The mass, the bigger you are, the harder you fall. It's also affected by your height. The higher you drop from, the harder you fall. And lastly, it's affected by gravity, which you can't change because you're stuck on Earth. Okay? So if you change the height, if you make this bigger, it's going to make this bigger. Okay? So if you increase the angle of the ramp, because you've increased its height, you've increased the amount of gravitational potential energy it had at the top of that ramp. So that's going to affect, of course, how much kinetic energy it's going to have, okay, when it gets to the bottom. Because remember, that transforms into that, except for what it loses with wasted energy. So that's angles. Now, last but not least was the friction mats. Okay, they were actually designed to slow the marble down. Why? Because the marbles were getting so much speed at some point that they were actually zipping off the ramps and all over the place. We had marbles going everywhere. So we introduced the friction mats. Now, if you have removed the friction mats, you're going to find that your marble is not slowing down as much, because, think about it, if it's slowing down, then it's losing energy for some reason. Okay? And the hint is in the name. So you have to think about now which one of these you did, how it affected and changed this energy diagram here. Because yes, the change you made changed that diagram. That's what you have to annotate and show us for the last part of this task. You have to show us how version 2 machine's energy diagram will look different than version 1 because of what you changed. And that's it in a nutshell. Well done.